You know, when you look up at the night sky, it seems so peaceful, almost eternal. But that calm, it's a beautiful illusion, because hiding out there, in plain sight, are events so violent they just dwarf anything we can possibly imagine. So today, we're going to pull back that curtain on the universe's most extraordinary, most powerful events. Okay, let's dive right in. So, just to get your head around the scale we're talking about, listen to this. This is about something called a gamma ray burst, or GRB. Try to imagine every single bit of energy our sun will ever produce in its entire 10 billion year life. Now imagine an event that unleashes way more than that, in just a few seconds. That's the level of power we are dealing with here.
But here's the really wild part, and this is kind of the whole point of our explainer today. This isn't just about destruction. All this staggering violence, it's creative. These explosions, these cosmic collisions, they're the furnaces that forged the heavy elements. They literally built our world. And yeah, they built us.
Okay, our first stop is probably one of the most famous cosmic events there is, the death of a massive star, the supernova. I mean, it's an almost unimaginable release of energy. You have a single star that, in its final moments, briefly outshines its entire galaxy of billions of other stars. But how does that actually happen? Because it's really not as simple as just a big boom. All right, let's break down what happens in what's called a core collapse supernova. It all starts when a star, one that's way bigger than our sun, finally runs out of nuclear fuel. See, with nothing pushing outwards anymore, gravity wins. It just takes over. The core collapses catastrophically, crushing itself into this super dense thing called a neutron star. Now that collapse sends out a shockwave, but it pretty quickly runs out of steam. It stalls out. The explosion should just fizzle. But it doesn't. And the secret weapon here is that brand new neutron star, which unleashes this biblical flood of tiny particles called neutrinos. And just a tiny fraction of those neutrinos get absorbed by the stuff behind the shockwave, reheating it, re-energizing it, and just boom, the star is blown to bits in this spectacular explosion. Now, this is really cool. This visualization shows us something that modern computer simulations have figured out. We might picture a star exploding in this perfect, neat little sphere, right? But the reality is so much messier. The explosion is lopsided, it's chaotic, it's fundamentally asymmetrical. So what's causing all that chaos? Well, there are two main things going on. First, you get this intense heating from the neutrinos that creates all this turbulence. It causes these giant bubbles of hot gas to rise up, almost like water in a boiling pot. And then on top of that, the entire shockwave itself can become unstable, and it starts this massive scale sloshing motion back and forth. This combination basically guarantees that the explosion is a lumpy, violent mess that stamps its unique shape on the debris for thousands of years to come. As totally insane as supernovae are, they are not the most energetic things out there. Not even close. That title belongs to the true champions of cosmic power, gamma ray bursts. Let's just go back to this number for a second. More than 1 billion times the sun's entire lifetime energy output. How is that even possible? How can one single event, lasting only seconds, concentrate that much power? Well, the secret is focus. A supernova kind of throws its energy out in all directions, like a bomb. A gamma ray burst doesn't do that. Instead, it funnels almost all of that incredible power into a pair of tightly focused, pencil-thin jets of material. And these jets are moving at what we call ultra-relativistic speeds, which is just a fancy way of saying more than 99.9% the speed of light. And what you're seeing here is exactly what that acceleration looks like. These are computer simulations of a GRB jet as it's being launched. The color shows something called the Lorentz factor. Just think of it like a cosmic speedometer where the needle gets infinitely close to the speed of light. See how at the bottom near the start the colors are blue? That's, slower speeds. But as you follow the jet outwards, it shifts through green, yellow, and finally to this deep red. That color shift, that's a violent acceleration, pushing the material right up to the cosmic speed limit. It's an incredible particle accelerator built by nature. Okay, so we've seen exploding stars and blinding jets, but there's a third cataclysm, one that was just a theory until a few years ago, the merger of two dead stars. And the stars we're talking about are neutron stars, the very same things left behind by supernova. I mean, remember, these things are just absurdly dense. A single teaspoon of neutron star stuff would weigh billions of tons here on Earth. We're talking about something with more mass than our sun, crushed down into a sphere that's no bigger than a city. Now, imagine two of these cosmic cinder blocks orbiting each other. As they do this dance, they're constantly shedding energy by making gravitational waves, actual ripples in the fabric of spacetime. This energy loss makes their orbit shrink, so they spiral closer and closer, faster and faster for millions of years until they finally slam into each other in a final milliseconds-long collision. And in that one tiny moment, wow, what a show it puts on. The collision creates a kilonova, which is this totally unique kind of explosion. It launches a short, intense gamma-ray burst, just like the ones we just saw. It sends out a powerful chirp of gravitational waves that we can now actually detect here on Earth. And, maybe most incredibly of all, it creates this hot, dense cloud of debris where hundreds of Earth masses of the heaviest elements in the universe are forged, including gold and platinum. And this is where we come full circle, right back to the creative power that's hidden inside all of this cosmic violence. You know, we've all heard that phrase, we are made of stardust. And it's beautiful, it's poetic, but it's also literally true. The iron in your blood, the calcium in your bones, all of it was cooked up inside a star that died a very long time ago. But that's not the whole story. See, for the really heavy stuff, we're talking about gold, platinum, uranium, even a supernova isn't quite enough. You need something even more extreme. You need the neutron-rich chaos of a kilonova. That wedding ring on your finger, the gold in it was almost certainly born during the cataclysmic death spiral of two neutron stars, probably billions of years ago.
So, if you take one thing away from all of this, let it be this. These explosions are not just endpoints. The supernova that seeds the galaxy with new elements, the kilonova that forges precious metals, they are these starting points. They are the violent but absolutely necessary acts of creation that make planets and ultimately life itself possible.
So these incredible events, they aren't just random acts of destruction. They're an essential part of the universe's great cycle of creation. It really makes you wonder, what other incredible things is the universe building right now, out there in the fire?